Hello, thank you for taking the time to view our production on a topic that is based off Lotka's law. This presentation was created by Team Rainbow Sharks Uniforms, which is composed of the following students: Amanda Mendieta, Johnny Nguyen, and Imran Majid. Alfred Lotka was born on March 2, 1880 in Austria-Hungary, which is now formerly part of Poland. Lotka grew up with a passion in math and science. He was a famous statistician, scientist, and mathematician, pursuing educations with a Bachelor of Science from the University of Birmingham, and later migrated to America to pursue a Master's of the Arts in 1909 from Cornell University. Following these educational endeavors, Lotka ventured back to England, where he received his Ph.D. in science. Lotka is best known for his predator-prey model, which is also known as the Lotka-Volterra model and equation. This model depicts equations that express the biological system when two organisms from different species interact, hence the term predator-prey. They evolve in time with accordance to their equations and their behavior. Lotka's law, named after the great scientist Alfred Lotka, was meant to study the law of scientific publication productivity used in library information sciences. There are many studies that have been completed proving Lotka's law to be true and to produce reliable results. Lotka's law can be used in library information sciences as a standard means of measuring author publication productivity in relation to the productivity on scientists, which leads to findings that are comparable on many levels. Lotka's law has been trusted as an empirically proven analytical instrument to establish publication productivity standards for professionals and faculty librarians. Okay, so now that we know the value of what Lotka's law brings to library information sciences, what does it mean exactly? Well, as we explained previously, at a high level, Lotka's law describes the dynamic frequency of publications of authors and scientists in any subject matter. Mathematically, as you can see, it is described as the equations are displayed. The number of authors creating Y contributions is about C over X to the n power. C almost always holds the value of 1, while n almost always holds the value of 2. These equations express that the number of authors publishing a certain number of articles is a fixed ratio to the authors who publish a single article. Therefore, as the number of published articles increases, that many number of authors publishing like articles decreases. For example, this would express that the number of authors writing 2 publications is 1 over 2 squared, which equals to 1/4 or 25% of those creating 1 publication. So those producing 3 publications would be 1 over 3 squared, which is equal to 1/9 or 11% of those making 1 publication, and so on. The power function predicts the distribution of the ratio and the overall percentage of those creating these publications. This information has been applied to a myriad scheme of publications such as artwork, articles, and magazines, as well as our most recently in our technological age can be true for information shared and used across the internet. Here is a chart further explaining the mathematical sense of Lotka's law. In the left column, we can see that the table indicates the number of articles written, and in the right, the number of authors writing the specific number of articles. As you can see, it displays that in the first data-filled row that we have 10 articles written. In the right column, it indicates 100 over 10 to the second power, which equals 1. Therefore, the 10 articles we have written for the specified scenario, we have 1 author who has created it. This chart indicates that the law only in its logical sense and does not represent a specific experiment that has been conducted with Lotka's law. However, there are many experiments that have been conducted in regards to these equations presented on the screen, and they have been proven to be true and reliable. The equations that are indicated are at times referred to as the discrete Lotka power function. This is a graph representation of the principle of Lotka's law, which explains at a high level of what our previous chart indicated. The x-axis indicates the papers written, while the y-axis indicates the percentage of authors writing these papers. As papers written increases, the percentage of authors obviously is in a decline. Lotka's law can even be applied in today's world of technology, such as web applications that are used for some on an everyday basis, such as YouTube, a hub for videos, Facebook, the ultimate social network, Wikipedia, the online encyclopedia, or the blogging site Tumblr, for some that are used as an online diary. Virtually any social media site that has a transaction process of user data and information can be linked back to what Lotka's law was trying to prove. The law also applies to many open source softwares that are on the rage today in development. Here is an example using data from stackoverflow.com, a website dedicated to a community of users that can submit inquiries and answers regarding information technology related questions. Does this graph look familiar? The y-axis shows the number of users and the x-axis displays the number of days it takes to post an answer. Initially it takes less time to receive an answer, but as time progresses it took more days before another answer was posted, making this seem less frequent. It applies to Lotka's law due to the fact that as more contributions were made to an article or question, over time the amount of people contributing to the inquiry will decrease. This application of Lotka's law occurs on many inquiry sites such as Ask.com, Yahoo Ask, and many others. Lotka's law can be applied to modern web enhancements and information sharing. Further example, websites that their well-being solely depends on the views of their users could potentially thrive on information to predict their users' next move and behavior. Justin Bieber, a YouTube and vocal artist sensation, has over 831 million views on his single, Baby, which was posted about 3 years ago to date. The math of these views occurred within the first time when this video was published, and after the length of time, views steadily declined. As more users viewed the video, the frequency at which it was viewed in a time of state had a stable decreasing. Lotka's law therefore can even be used to predict the views for specific content on a website, and even explain users' behavior toward like videos that are being posted, to an extent. As we have seen thus far, the application of Lotka's law has a very relevant presence in social media. Lotka's law can be thought of as a creation law in information systems, in which those creating either information or web tools will decrease as more others like it come about. This is true in open source software, for example. As the number increases of Linux development for specific applications, the number of developers begin to decrease, creating this ratio. In conclusion, we have learned through this presentation that Lotka's law was initially an inverse power function that was created for library information sciences to predict the ratio of articles published by authors. And after this presentation, we can also conclude that Lotka's law can be used today for information technology predictions, such as web application development, hits on a blogging site, or even a video hub site. This slide indicates the works cited that we used to create the presentation you viewed today. On behalf of my team, we would like to thank you for viewing our video today. Thank you.